Hello, thank you for visiting Deloach Education on YouTube. I'm Gary Deloach. In this video, we will be dividing up to 4-digit dividends by 2-digit divisors. The first problem we're going to work out is 7,482 divided by 24. In this particular example, we're going to use the standard algorithm. The next example, we'll use the partial quotients method, which is also known as the Big 7 method. So, in this problem, my divisor is 7,400, or excuse me, my dividend is 7,482. And the dividend is the number that goes inside of the box. It's the number that is being divided. So we're going to divide 7,482 by 24, which is our divisor. So you place that number on the outside of our box. Now, when I am doing long division or problems with larger numbers, what I like to do is guess and check. And my guess isn't just a random off-the-wall guess. I actually think about the numbers and the relationships between them and other numbers to try to help me figure out which digits to place in my quotient. So my divisor here is 24. So what I'm going to do is look at 24 and say, okay, that's close to 25. Look at, I know that 24 can't go into 7, so I have to look at 24 into 74. And I can say, okay, 74 is close to 75. Well, if you think about money, if you have 3 quarters and their value is 25, you're going to have 75 cents. So 24 will more than likely go into 74 about 3 times. So off to the side over here, I am just going to verify that my guess is correct. So 24 times 3 is 72, so therefore it's less than 74. So I'm going to put a 3 up here in the hundredths place and subtract 72 from 74 to get 2. Now, we're going to bring down this 8. 24 will go into 28 once. That one's relatively easy. No guessing and checking needed there. 24 times 20, or 28 times 24 is 4. Bring down the 2. 24 I know cannot, or can go into 42 only once. So I'm going to subtract 24 from 42. And we get 18. So that 18 down there is our remainder. So off to the side, I'm going to write remainder 18. Now, I just want to double check to make sure that my work is correct. I recommend that to any students who are working on long division. It's just a safeguard so that way if you're taking a test or something, or even just working on your homework, you can verify that your answer is correct. And if it isn't, you can find out what the correct answer is. So we're going to multiply 311 by 24. What I'm doing here is taking my quotient and my divisor and multiplying them. So 4 times 1 is 4, 4 times 1 is 4, 4 times 3 is 12. Put in your 0 here because now I'll multiply by the 2, which is in the tens place. 2 times 1 is 2, 2 times 1 is 2, 2 times 3 is 6. Add up those partial products, we get 4, 6, 4, 7. That doesn't match our dividend, but you got to remember to add your remainder. So I'm going to add 18 to 7,464, and we get 7,482. So our product in our checking matches the dividend in the problem that we were given. Alright, so now we're going to switch gears and go over to the partial quotients or the Big 7 method. So partial quotients is also known as Big 7, and I've also heard of it referred to as chunking. So the reason why we call it the Big 7 method, or the reason why it has that nickname, because when you set up the division box, it resembles a Big 7. So again, the same procedures that you use for long division and setting up will be the same procedures that you use with partial quotients. The nice thing about partial quotients is you don't have to have the exact number every time you're subtracting. So like in the last problem, when we did the standard algorithm, we needed to write that 3 above the 4 to say that 24 goes into 74 3 times. With the Big 7 method, we can take out chunks of numbers at a time until we can no longer subtract from the remainder. Um, or, I'm sorry, divide the remainder. So let's just say I don't know that 24, how many times 24 goes into 74. I do know that I'm dealing with the hundreds place, so it will be a number in the hundreds. So I'm just going to start with 100. So 24 times 100 is 2,400. And what I'm going to do is just subtract 7,482 from 2,400. When I do so, I get 5,082, which I still can subtract groups of 24 from 5,082, and it looks like I can get another group of 100 or 2,400 out, or 2,400 that is. So 5,082 minus 2,400 gives me 2,682. Well, I can still take out another group of 2,400, and then I'm left with 282. Well, I figured out how many times 24 will go into 282. I know that 24 times 10 is 240, so I am just going to use 10 here. And I should have mentioned this from the beginning, but it's best to use multiples of 10 and 100 because they're easier to compute than choosing numbers like 15 or 16 or 17 or 18. So that's the nice thing about partial quotients, is being able to target those multiples of 10. So 24 times 10 is 240. Try 240 from 282. I'm left with 42. Well, I know that 42 is greater than 24, so I should be able to get another group of 24 out. So I'm just going to take 1 away. 24 times 1, 24. So 42 minus 24 gives me 18. So now, my remainder is going to be 18 because I can no longer divide, or I can't divide it by 24. So how do I figure out my quotient? Well, you'll notice off here to the side we have 100, 100, 100, 10, and 11. Or, I'm sorry, 1. I'm thinking ahead of myself here. So what I'm going to do is add those up. So 100 plus 100 is 200, plus another 100 is 300, plus 10 is 310, plus 1 is 311. So adding all those numbers up, and those numbers are our partial quotients, hence the name partial quotient method. So we add all those up to get our actual quotient, which is 311. And then we just take this remainder down there and write it off to the side. So it's 311 remainder 18. Just like in the last problem, I want to verify that the quotient that I got matches my the quotient times the divisor plus the remainder will match my actual dividend in the original problem. So 4 times 1 is 4. 4 times 1 is 4. 4 times 2 is 12. Putting here 0 because we're multiplying by the 2. In the tens place, 2 times 1 is 2. 2 times 1 is 2. 2 times 2 is 6. Add those numbers up. We get 4, 6, 4. So 7,464. Don't forget about the remainder. Add it. 1. So 4 plus 8 is 12, carry 1, 4. I'm sorry, 1 plus 6 is 7, plus 1 is 8, 4, 7. So 7,482. So our quotient times our divisor plus the remainder is 7,482, which matches our dividend in the original problem. So those are just 2 examples, one using the standard algorithm, the other using partial quotients. And both these methods can be used for not only dividing up to 4-digit dividends by 2-digit divisors, but numbers that are smaller and or larger than 4 and 2. As always, if you have any questions, you're more than welcome to comment below, or you can email me at deloacheducation@gmail.com. If you're a student and you're in my class, you can just ask me during class. I hope this helps you with your long division. And if you need any other help, check out some of the other videos posted on this page. Thanks again for watching.